is show you another magic. I am going to start with Newton's laws. Equals any applied force, right? That means MA results from M applied. Agree? So now there are two possibilities. One possibility is that that applied force exists over a long period of time, or it could exist over a short period of time. When it exists over a short period of time, we call that applied force impulse. And when it applies over a long period of time, we call it just the applied force. A bat hitting a ball, it applies a force on it. It's called what? Impulse. It lasts for a very short period of time. Based on these two definitions of applied force, two different theorems are developed. One of them we just did, which was called the work-kinetic energy theorem. The other one is called the impulse-momentum theorem. Let's develop them, starting from the same equation. In our minds, when we do intro one, it is more than likely that we think that they are two different ones. They are not. They're the same one. Okay, they start from the same exact point, and the only difference is the amount of time that is required. Ready? Okay, which one do we want to do first?
Let's go with impulse.
Wait, both of you are saying there's the other things.
Which one's shorter?
Both of them have like 3 steps. So, okay, go with longer first because it's on that side. Okay, I'm gonna go with the longer one. I agree. Okay, so we're starting from the same equation that is in the box, correct? MA equals F applied. This can also be written as M dV over dt equals F applied. Can I multiply this with dx? Okay. Can I combine these two? And can I move this over? Can I integrate both sides? What comes out in the left-hand side? Where the limits of integration are from V0 to some final V. What goes on the right-hand side? So automatically pops up a theorem which we call the work-kinetic energy theorem. I did not do anything fancy at all. Do you see how simple it is? Just manipulation of a few simple things. You guys ready to do the other one? Okay, we're always starting from the same equation. Now, remember, time is very small for this case. It's a very short interval of time. So we're going to do the same steps. We are going to move this to the other side. So we are left with M dV equals F applied dt. Can anyone think what's going to happen next? What's our next step? Always. From what to what? From V0 to some V final. This side is defined as impulse. Just like this side was defined as work, this side is defined as impulse. On our left-hand side, what do we get? What's that the formula of? MV? Good. So this is P final minus P initial, which is This is called the impulse-momentum theorem. So simple. All I needed to do was change one slight thing, and the entire process changes. And it develops into this beautiful theorem that we do in chapter 7 of our textbooks. And part of the reason why it's so difficult to put these things together is because when we do chapter physics 1, they are in such different chapters that we never put them together. That's why it's important to see them and where they develop from.